So, solving system of equations with 3 equations and 3 unknowns. If I do this, I want to take 2 equations at a time. In those 2 sets of equations, I want to eliminate the same variable. So I'm going to start off just with my top 2 equations. If I have x minus y plus 2z equals negative 3, and negative x plus 3y plus z equals negative 2, since my x's are already opposite, I'm going to eliminate the x's. In theory, you could eliminate the x's, the y's, or the z's, but it's less work for me to get rid of the x's. So I'm just going to go ahead and add. Those are going to cancel out. I'm going to get 2y plus 3z equals negative 5. Then what I want to do is either use the first equation with the third one or the second one with the third one. I want to eliminate the same variable, so I want to eliminate the x. To me, it looks a little easier to use the first one, so I'm going to use the first one with the third one. So I'm going to have x minus y plus 2z equals negative 3, and negative 3x plus 2y minus 4z equals 1. What I'm going to do there is I want to eliminate the x's. So I need to make opposites. Since this has a negative 3, that has a 1, I'm going to take this times positive 3, make opposites. Everything in the top equation there times 3. So 3x minus 3y plus 6z equals negative 9. Adding those together, the x's cancel. I get negative y plus 2z equals negative 8. Now I'm going to use this equation with this equation. So I have 2y plus 3z equals negative 5, and I have negative y plus 2z equals negative 8. So thinking of that as my system of equations with 2 variables, I can either get rid of the y's or get rid of the z's. The y's look easier to get rid of, so I'm going to go with the y's. I'm going to multiply my bottom equation times 2 so that I have opposites in front of my y's. So negative 2y plus 4z equals negative 16. All right, so when I add my 2 equations together up here, the 2y and the negative 2y cancel out. 3z plus 4z would be 7z. Negative 5 minus 16 would be negative 21. Dividing by 7, z then equals negative 3. I found z. I need to still find the x and the y. First thing I'm going to do is go back to one of these 2 equations and find my y using that z is equal to negative 3. So if I use this top one, I had 2y plus 3 times z, which is negative 3, equals negative 5. So putting negative 3 in for my z. 2y minus 9 equals negative 5. I'd add my 9. 2y equals 4. I would divide by 2, so y equals 2. So I found z, I found y, I still need to find x. In order to find x, I have to go to one of my original equations, substitute in the 2 for y, the negative 3 for z. So I'm just going to use the top one. X minus the y value of 2 plus 2 times the z value of negative 3 should equal negative 3. So x minus 2 minus 6 equals negative 3. X minus 8 equals negative 3. So adding my 8, x would equal 5. So I got answers of x equals 5, y equals 2, and z equals negative 3. If I wanted to double check that to make sure it was right, I would substitute it into either one or both of those equations and double check. I'm just going to check in the bottom one. So negative 3 times the 5 would be negative 15. 2 times 2 would be positive 4. Negative 4 times negative 3 is a positive 12. So 4 plus 12 is 16. 16 minus 15 is 1. Yes, that checks out. So this is going to be my answer. So use 2 of your equations together, and then use two other equations together. One of them obviously you have to repeat on. Eliminate the same variable. Then you have two equations with two variables that you can solve. Then go back to your original equations, find your missing variable, and then check your answer. So if we go to number 14 here, solving our system of equations. So at 4x plus 3y minus z equals 0, negative 2x plus y plus z equals negative 8, 3x plus 4y minus 2z equals negative 4. Again, I notice if I use the first two equations, my z's are opposite, so I'm going to go ahead and eliminate my z's. And so if I have 4x plus 3y minus z equals 0, and negative 2x plus y plus z equals 0, and I add them, z's are going to cancel out. So 4 minus 2 would be 2x, 3 plus 1 would be plus 4y. Whoops, this was supposed to be equals negative 8 if I could copy my problem down correctly. Negative 2x plus y plus z equals negative 8, so 0 plus negative 8 would be negative 8. So I want to eliminate my z. I want to use my third equation with one of my other two equations. I'm going to do it with my second one just because that one has a positive and that one has a negative. So using my second equation and my third equation, negative 2x plus y plus z equals negative 8. 3x plus 4y minus 2z equals negative 4. If I want to get rid of the z's, I'm going to take this top equation times 2 to make opposites. So everything in the top equation times 2, I get negative 4x minus 2y plus 2z equals negative 16. So 2 times negative 2 is negative 4. 2 times 1, that's supposed to be a plus 2y. Good thing I'm checking. So negative 4x, a plus 2y, a plus 2z, and a minus 16. Now, after I have that multiplied out, my z's should be opposites. They're going to cancel out. 3x minus 4x would be minus 1x. 4y plus 2y is a plus 6y. That's going to equal negative 4 minus 16, which is minus 20. So now I'm going to take this answer for my equation and this one, put them together. So 2x plus 4y equals negative 8. Negative 1x plus 6y equals negative 20. Looking at those two equations as my systems of equations, I'm going to get rid of the x's. If I get rid of the x's, to make opposites, I just need to multiply the bottom equation times 2. So I would have negative 2x plus 12y equals negative 40. So I'm going to add my top equation plus my new equation. 2 minus 2 is 0. 4 plus 12 would give me 16y. Negative 8 minus 40 would be negative 48. And again, to solve that, I just need to divide by my 16. I believe that's negative 3, but let me just double check here. 48 divided by 16 is 3. So yes, negative 3. I found my y value is negative 3. Going to go back up here to find my x value. So I know that 2x plus 4 times my y value, which is negative 3, equals my negative 8, just substituting in the negative 3 for the y. So 2x minus 12 equals negative 8. Adding my 12, 2x would equal 4, and dividing by 2, x equals 2. So I found my x, I found my y, I still need to find my z. I can use any of these three equations. I'm going to use this one here in the middle because it looks a little easier to use. So I'm going to use the negative 2 times x, which is 2, plus the y, so plus a negative 3, plus z equals my minus 8. You can use any of those three. I just picked the middle one because it looked easier to do. So negative 4 plus a negative 3 plus z equals negative 8. That would be negative 7 plus z equals negative 8. When I add my 7, z is going to equal negative 1. Should have used a different color. It's running into my red. So what I came up with is x equals 2, y equals negative 3, and z equals negative 1. Again, just to double check myself, I'm going to plug it into my bottom equation and see if it works out okay. So 3 times 2 would be 6. 4 times negative 3 would be minus 12. Negative 2 times a negative 1 is a plus 2. 6 minus 12 is negative 6. Negative 6 plus 2 is negative 4. Yep, that checks out okay. So those must be my solutions. 2, negative 3, and negative 1. One more of those. I hopefully left myself enough room to write here. Again, I'm solving my 3 by 3 system of equations. If I look at my top 2 equations, the x's are already opposite, so I'm going to go ahead and get rid of the x's. So I have negative x plus y plus z equals negative 1. I have x plus y minus 2z equals 7. Adding those together, the x's will cancel. So I get 2y minus z equals 6. So I want to look at that. I want to get rid of the x's. Since this is a positive 4x, I'm going to go ahead and use the first one with the bottom one. So I'm going to use the negative x plus y plus z equals negative 1 with my 4x minus 2y plus 2z equals negative 4. I'm going to go ahead and multiply the top equation times 4 so that again I can eliminate the x's from my equation. So negative 4x plus 4y plus 4z equals negative 4. So the x's cancel. Negative 2 plus 4 is 2y. 2z plus 4z is 6z. Negative 4 plus negative 4 is negative 8. So 2y plus 6z equals negative 8. So I'm going to take this answer for that equation, this answer for that equation, and work those two together. So I have 2y minus z equals 6. I have 2y plus 6z equals negative 8. So I have a 2y and a 2y. If I take one of those times negative 1, I can just switch my signs. So negative 2y minus 6z equals a positive 8. So 2y minus 2y, those would cancel. Negative z and a negative 6z would be negative 7z. 6 plus 8 is 14. When I divide, z is going to equal negative 2 then. I found my z. I want to find my y. So 2y minus my negative 2 should equal 6. 2y plus 2 equals 6. If I subtract my 2, 2y equals 4. Dividing by 2, y equals 2. So I found y and z. I want to find x. Again, looking at this, the middle one to me looks a little easier since I just have the plain x there. I'm going to use my middle equation and say that x plus my y value, which is 2, minus 2 times my z value, which is negative 2, should equal 7. So x plus 2 plus 4 equals 7. X plus 6 equals 7. If I subtract my 6, x equals 1. So I got answers of x equals 1, y equals 2, and z equals negative 2. Going to go back and check those, and I like to check it in the bottom one just for fun. So 4 times 1 is 4. Negative 2 times 2 is a minus 4. And 2 times negative 2 is a minus 4. And so 4 minus 4, that's 0. Negative 4 equals negative 4. Yep, it does. So I should have answers of 1, 2, and negative 2.